You get up to go to the gym at 5 a.m. with your best bud. You get to the gym and you're lifting weights, you're getting it done. And then you overhear this conversation between this other dude and his friend, and this guy's like, yeah, I've been taking testosterone injections and it's really making my strength capacity go up and my muscular endurance go up. So you pause and you think about it and you ask yourself, but what is testosterone actually doing to the human body on the molecular and physiological level? Well, you know what? Let's talk about the science behind that.
Welcome to The Science Behind That with Atticus Hamilton.
Hello all you scientists, and welcome back to The Science Behind That. As you heard from the intro, I am your host, Atticus Hamilton, and look, ladies and gentlemen, before we dive into today's episode, which is surprisingly about a topic that is kind of controversial for some reason. Anyway, before we jump into today's episode, I want to say that first, I recognize that I took a really long break again, and I apologize for that, but you know what? I have really bad time management skills. I'm trying to get better at it, but that is just one of my character flaws. So, that being said, during this excessively long break, some might say, that I took, something really fantastic did happen, which is the podcast reached over 1,000 listeners. For that, I can't thank you guys enough. This is not the special 1,000 listener episode. That will be coming out this Monday, so stay tuned for that. And again, with that one, it's kind of like not safe for work or school if you're not in medical school. Like, if you're in medical school, fine, that's totally cool. But if you're not in medical school, I probably wouldn't be playing this on your Bluetooth speaker during lunch. That being said, ladies and gentlemen, let's jump into today's episode. But first, grab yourself a cup of coffee, add a little bit of maple syrup to it. Not too much. You don't want all that fructose, just a little bit to bring out those autumn spice flavors and that taste of fall in your coffee. And let's jump right in. So, some of you may already know why I'm doing this episode. And long story short, some things happened recently in the news where the action of testosterone, i.e. what testosterone actually does, has been called into question. Ladies and gentlemen, this is not a news and views podcast, so I'm not going to go into the details of where this idea came from. But this is a science-based podcast. So, that being said, the science of testosterone is actually quite fascinating and it's quite interesting. So, let's start with the beginning. So, a child is born, right? And this child has an X and a Y chromosome. And so once this young boy reaches puberty, interesting things begin to happen. And the most interesting thing is that DHT is starting to be produced at much higher levels than in his female counterparts, right? So, what is DHT? Well, DHT stands for dihydrotestosterone, and it is essentially a seismogen of testosterone. Now, before we continue, let me quickly define what a seismogen is. So, a seismogen is essentially an inactive form of a molecule, right? So, how are seismogens made? Well, seismogens can be made any number of ways, but a lot of times you take the original molecule that is essentially the scaffold of the seismogen, and you have some sort of functional group inserted onto this scaffolded molecule. And the insertion of that functional group inactivates the entire molecule. So essentially, dihydrotestosterone has two hydroxy groups attached to it. And those hydroxy groups, or HO groups, those inactivate the testosterone molecule. Now, what does this mean? Well, what this means is that DHT, it has to be converted into testosterone. Now, not all the DHT produced is converted into testosterone, but a vast majority of the DHT produced is converted into testosterone. So once the dihydrotestosterone is converted into testosterone via the removal of these two hydroxy groups, then the resulting testosterone molecule itself can actually begin the process of human development from the time of puberty to around around adulthood. Now, it is important for me to note here that testosterone doesn't stop once somebody turns 18, 21, 22. It's the production of it is not as high necessarily as it was when the young kid is going through puberty. And also, the, developmental changes are nowhere near as significant as they are when the child first starts going through puberty at about age 13. So, what does testosterone do? Well, everyone knows that testosterone is the male sex hormone. And even today, there's still some, uncertainty over the exact mechanisms, the exact things that testosterone does in the human body. However, in new research by Dr. Harrison Ween from the National Institutes of Health, it was determined that testosterone is vitally important for the development of sex drive, obviously, bone mass, fat distribution, muscle mass, muscle strength, the production of red sperm cells and of red blood cells, and the production of sperm cells. But more than that, testosterone plays a vital role in strengthening the skeletal muscle of the human body and increasing bone density. Now let's start with, in my opinion, the easiest place to start, which is how does testosterone increase bone density? The short answer is that it essentially stimulates osteoblasts to produce more bony matrix, right? Now, in the bone, you have three different types of blood cells. You have osteocytes, osteoblasts, osteoclasts. Osteocytes are mature bone cells. Osteoblasts are premature bone cells. And osteoclasts are a special type of fused macrophage that breaks down bone, right? Long story short, it's the osteoblasts that produce the actual hard stuff of the bone, which is bony matrix. The bony matrix is predominantly composed of a compound called hydroxyapatite, which I'll spare you from the complex chemistry there because that's a doozy. But it is theorized that what testosterone does is in young men, when they're actively going through puberty, what testosterone does is it stimulates those osteoblasts to produce more high-density hydroxyapatite. So one thing that I think a lot of people don't realize is that hydroxyapatite comes in different percentages. The most percentage hydroxyapatite source in the human body is our teeth, right? Our teeth are about 95% hydroxyapatite compared to between 72 and 85% hydroxyapatite in the bone. And so what testosterone most likely does to increase most bone mass is it aids in the stimulation of osteoblasts to produce more hydroxyapatite, resulting in higher density bones. Now, what does high density bone mass mean? Well, that basically means that your bones are stronger. They're less prone to fracturing. In addition to that, collagen also comes into play here a lot because collagen adds the flexibility to bone that you need in addition to the strength. And so continuing on with this, testosterone also could theoretically increase the production of collagen within the bones by the chondrocytes. So that's a theory, I guess the leading theory, of how testosterone increases bone mass. So as for muscle strength, the explanation of what's occurring there is, I guess, not as straightforward because it's recently, it's been really difficult to actually determine what is occurring on a physiological level within the myocytes that's facilitating increased mass and increased strength. Now, I have my own personal theory, which I will share with you, but it is important to note that as of right now, there's very little conclusive information as to what about testosterone is the contributing reason why it increases muscle strength and muscle mass. But I will contribute my own personal theory. So my personal theory is that maybe, much like with bone, maybe the testosterone is increasing the efficiency of calcium ion release and contraction within the muscle cells themselves, right? Now, this requires a little bit of background on how muscles work, which we're going to go into. I love muscles and bones, in case you guys haven't figured it out already. But the way muscles work is essentially, let's say you're at the gym, and you're like, you know what? I'm going to do 60 hammer curls. 1, good on you. That's awesome. And 2, the way that works is you pick up the weight, right? Let's say it's, 15 pounds. Brutal workout, by the way. Everyone should try that. Do 3 sets of 60 hammer curls at 15 pounds. Ooh, your arms will be throbbing by the end of it. Anyway, so you pick up the dumbbells, right? And when you're holding the dumbbells, you curl them. You do a standard hammer curl. And what's happening is your brain is sending a signal to your muscles via your motor neurons. And at the neuromuscular junction, what happens is these motor neurons stimulate the release of calcium into the muscle. Now, calcium goes down the myofibrils, and basically what it does is it exposes a filament called actin. And once that actin filament is exposed, it will bind to another filament in the muscle called myosin. And when that happens, the muscle contracts. Now you may be saying, well, how does calcium expose actin? Actin in a normal non-flex state is bound to another protein called troponin. And what the calcium does is it binds to the troponin, and it changes the binding affinity of the troponin to the actin, which then exposes the actin to a myosin head that's upright at a 90-degree angle. And that myosin head is actively hydrolyzing ATP, which is what allows it to go upright. And once the myosin and the actin binds, that contracts the sarcomere. And the sarcomere is basically, long story short, this is a little more complex than I want to go, but the sarcomere is basically the unit of contraction within a myofibril. So my personal theory then is that maybe testosterone increases muscle strength, maybe because during puberty, it somehow increases the efficiency of calcium to troponin binding and actin to myosin binding, which would make sense because if that's more efficient, then you utilize less ATP and you're able to lift more, right? And then continuing on with that, my other theory is that along with that, maybe during puberty, what testosterone does is it increases the size of the individual muscle sarcomers. But again, ladies and gentlemen, this is just my own personal theory. I couldn't actually find a specific answer of what's occurring. So it is an area of research that definitely should be done. All right. So that's the main thing, right? It induces fat redistribution, increases bone mass, increases muscle mass, increases muscle strength. All of those things are affected by testosterone. And now, there are a couple things I'd like to add as we approach the end of today's episode, right? The first thing is that both men and women have testosterone because testosterone is vital for everything I just said. Muscle size and strength, bone growth and strength, and sex drive. The only difference really is concentration. So on average, women will have between 10 and 30 nanograms per deciliter of testosterone. And that's compared to men who on average have between 300 and 1,000 nanograms of testosterone per deciliter. And that doesn't sound like a lot, but in reality, it is a lot. It is a lot because that excess of testosterone dramatically increases bone growth, i.e. bone density, bone strength, muscle size, and muscle strength. And again, the actual physiology of how it does this is a little murky, but it is definitely an area of research that should come into the limelight, I guess, because it's important that we all learn as much about our own physiology as we can so we can live as happy and as healthy as we can. Now, ladies and gentlemen, one final kind of funny side note before we end today's episode. I hope all of you remember at the beginning of the episode when we talked about DHT. So ironically, DHT, or dihydrotestosterone, in men is a big contributor to hair loss, especially in men who already have genes for alopecia. And it's kind of funny because what it basically does is it results in a thinning of the hair follicles, which over time can result in hair loss, which is also why we in the medical field see a lot of young men in their between ages 20 and 30 come into hair transplant clinics. Because during exercise, whether or not you're a man or a woman, that's irrelevant. During exercise, we all produce testosterone and estrogen. It's just for men, much lower estrogen, and for women, much lower testosterone, but we all produce that. And the irony is, the more you exercise, the more testosterone you produce, but again, you first produce DHT, and DHT has been linked to a thinning of hair follicles and hair loss in men. With that, ladies and gentlemen, I am going to say thank you very much for listening to today's episode. Definitely stay tuned for Monday because that is when the 1,000 viewer special will come out. And until then, everyone have a fantastic weekend. And remember, as always, stand up and question everything.